What is a DR and BDR? In OSPF, open shortest path first, the designated router, DR, and backup designated router, BDR, are elected in multi-access networks, e.g. Ethernet, to reduce OSPF overhead. Instead of all routers forming adjacencies with every other router, they only form adjacencies with the DR and BDR. This reduces the number of OSPF adjacencies and LSAs, link state advertisements, optimizing the network. Key roles: designated router, DR, acts as the central point for exchanging OSPF updates. It collects LSAs from other routers in the network and floods them to ensure synchronization. Backup designated router, BDR, monitors the DR and takes over if the DR fails, ensuring continuity. Why do we need DR and BDR? Imagine a multi-access network with 5 routers. Without a DR/BDR, each router would need to form adjacencies with every other router. This results in n/2 n/1/2 n/1/2 adjacencies, leading to excessive OSPF traffic. With a DR and BDR, each router forms an adjacency only with the DR and BDR, reducing the number of adjacencies dramatically. How are DR and BDR elected? OSPF priority. Each router interface has an OSPF priority, default, 128. Higher priority increases the likelihood of being elected as DR or BDR. Priority 0 means the router is ineligible to be DR/BDR. Router ID. If priorities are the same, the router with the highest router ID is elected. Router ID is determined by manually configured router ID. Highest IP address of a loopback interface. Highest IP address of any active interface. Election process. Initially, a BDR is elected. Then, a DR is elected. Other routers become DR others and only form adjacencies with the DR/BDR. I captured this image from the Mikrotik wiki, which illustrates the broadcast segment and explains how OSPF LSAs are calculated. Let's review the same lab we set up in part 2 of the previous video. I recommend watching parts 1 and 2 before proceeding. Here, we will determine who the DR and BDR are in the broadcast domain. Let's start by checking who the DR is. Let's navigate to the main office and Office 1 routers. Go to the OSPF Neighbors section and check the PTP connection from Office 1 to the main office, and vice versa. This will help us identify the DR and BDR in the neighbor relationship. Here, we can see that the Office 1 is the designated router, and Home Office is the backup designated router, as it has the highest IP address. Next, let's navigate to the OSPF interface template. Let's adjust the setup to ensure the main office becomes the DR. Will increase the priority of the main office so it's higher than Office 1. Remember, the router with the highest priority will take the role of DR. Let's bring down the OSPF process on both the main office and Office 1 routers, then restart it to verify if the main office is now elected as the DR. Great! We can now confirm that the main office router has been successfully elected as the DR in the network. And Office 2 has been successfully elected as the BDR in the network. Next, to ensure stability in our OSPF network, we will designate the main office router as the DR. This will prevent any other routers from being elected as DR or BDR, eliminating unnecessary overhead. The main office router will handle the OSPF database, ensuring efficient and stable routing. The main office will have a higher priority, while Office 1 and Office 2 will have a priority of 0. This ensures that the main office is always elected as the DR, with no chance for Office 1 or Office 2 to become the designated router and backup designated router. Let's disable OSPF on all the routers, then enable it again to observe the final result. Here, we can see that the main office router has been elected as the DR, while Office 1 and Office 2 are in the derouter state, meaning they are neither the DR nor the BDR in the OSPF network.